Hello and welcome to your warm-up. And look at this. It only has a front. There's no back to this warm-up. Can you believe it? It's your lucky day. All right. How does fuel consumption of a car change as its speed increases? Here are data on the British Ford Escort. Speed is measured in kilometers per hour, and fuel consumption is measured in liters of gasoline used per 100 kilometers traveled. Yeah, the rest of the world uses the metric system. Why not us? Who knows? Using your graphing calculator, make a scatterplot. I suppose you could also make it by hand. Describe the form of the relationship. Explain why the form of this relationship makes sense. All right, so here I have my calculator. I have already taken the liberty of entering the data. So L1 has all of the speeds from 10 all the way up to 150. And L2 has the fuel used. So again, I just kind of did this to save space, but like this is all like one big table, and these are going to be my X's, these are going to be my Y's, these are still the X's, these are still the Y's. I just broke it up this way so that it didn't take up as much space. All right, so try to refocus it a little bit there. Now that I've got that in there, I'm going to go to second y equals. I'm going to go to plot 1. I'm going to make sure that it's on. And then the scatter plot is the very first choice. All right, so the scatter plot should just be your very first choice. And then you can go to zoom 9. And you should get your scatter plot. And it should look something like this. All right, so as far as what I'm looking for here is I just need sort of a general sketch, but you should label the axes. So you should tell me that, okay, this is my speed, and this is my fuel. And then I'm basically at this point just looking for the general shape of it. So something like this is all I'm really looking for. All right. Obviously, I didn't just measure anything out. I didn't check the dash lines. I'm basically just looking for a general sketch of what's happening. So in terms of describing the form of the relationship, we could say that it is curved. And why does this make sense? It takes a lot of fuel to start moving. Then the car gets more efficient because you've started moving, right? You don't have to overcome that initial inertia. Before eventually losing efficiency as you drive at high speeds. All right, so there's sort of this sweet spot for cars where it takes a lot of fuel just to get moving at the start because you have to overcome the initial inertia and the friction there. And then as you get moving, it gets more and more efficient, but that sort of reaches its limit. And then if you want to go really fast, all right, you're going to have to start using more fuel to do that again. There have been times in this country's history where there's been like fuel shortages. And when they do that, they usually will lower the speed limits on the highways, because by lowering the speed limits, the cars tend to be more efficient, which means that they're not going to use as much gas. So this sort of pattern that we're seeing is what you would expect with a car. It takes a lot of fuel to start. It gets more and more efficient. And then eventually, if you want to keep going faster, you're going to trade off and lose some of that efficiency. All right. Does it make sense to describe this variable as either positively associated or negative associated? No. And why? So the answer would be no. And the reason is it's both. All right. It depends on where you're looking at the graph. No, because it switches from a negative association at the start, which means that as your speed goes up, your fuel consumption is going down, to a positive association at the end, which is where as your speed goes up, so association at the end, which is where as your speed goes up, so does your fuel consumption. So from this section, it's negatively associated. At this section, we could think of that as positively associated. So it doesn't make sense to describe the whole graph as either negative or positive. You could maybe describe parts of it as negative or positive, but not as a whole. Now, is the relationship reasonably strong or weak? Explain your answer. So it's not a linear relationship, but it's clearly a very strong relationship, all right? This is following a very clear and established pattern here, right? It's not like the points are scattered all over the place and like some are up and some are down. So it's a very strong relationship. It just doesn't happen to be a linear relationship, all right? The relationship is extremely strong as it seems to follow a precise curve pattern. Right? We might not know exactly what this equation is or what that pattern is, but it's clearly following some sort of very established pattern. All right, we're not seeing like, oh, this one goes down, but then the next one is up, and then this one's back down, and then this one's up. All right, it's following a very set pattern. We just don't know exactly what that pattern is. We don't have an equation for that pattern yet, but it's clearly following like an established pattern. So again, just kind of recapping quick, there's the sketch of our scatter plot, and I don't need it to be exactly hashed out and everything else, but I do want to know what the overall shape is, and I do want you to label your axes. All right, for right now, we can just call this like a curved relationship. Positive and negative association isn't going to really apply in this sort of situation because it sort of does both. But normally, if we had a line just like this, we'd say it's positively associated. If we had a line like this, we'd say it's negatively associated. And then when we're talking about the strength of the relationship, we're saying like how closely does it follow the pattern. So in this case, it's following it pretty closely. All right, we're not seeing a lot of deviation from this sort of curved pattern that's being established here. All right, so again, these are just sort of the key things that you want to hit on when you're looking at a scatter plot and when you're describing a scatter plot. What's the form? Is it positively or negatively associated? Is the relationship strong or weak? And then also we would comment on outliers, but we don't really have any outliers here because nothing's really breaking from the pattern. All right, so when everything's following the pattern, you're not really going to have any outliers. All right, so again, that's it for today as far as the warm-up is concerned. So I hope this was helpful. If you have any questions, let me know. All right, bye.